So this is another way to do question number 2, and it might appeal to you a little bit more. So we're going to start with the same situation. We're going to rewrite this expression as 10 to the k times 10 minus 7 to the k times 7. And again, this is a little irksome because I know that I need to have a 10 to the k minus a 7 to the k. And I can't factor anything out. But I'm going to create something because here I have a 10 to the k times 10. So what I'm going to do is this. 10 to the k times 10, and I'm going to subtract 7 to the k times 10. But I can't really arbitrarily subtract it because that's adding something. So I'm going to add it right back. So I'm adding negative 7 to the k times 10 and positive 7 to the k times 10. So essentially I'm adding 0. And that allows me to be a little bit creative because then I can group these two terms together and I can factor out that 10, which leaves me with the 7 to the k, 10 to the k minus 7 to the k that I was after. And then for my next terms, I can factor out a 7 to the k, which leaves me with 10 minus 7, which, lo and behold, is 3. So I have 7 to the k times 3. And then for this first group, I can replace 10 to the k minus 7 to the k with, well, that was originally 3 times p. So now I can definitely just factor a 3 out of this term and this term. So that gives me 3. 10 times p plus 7 to the k. Okay, again, p always was an integer. K is a natural number, so 7 to the k is an integer. So I know that this is just some q. So I'm going to call that 3 times q, where q is an integer. And that's always what we were looking for.